Hello everyone, we are here to talk on electrophoresis, different types of electrophoresis such as agarose electrophoresis, polyacrylamide electrophoresis, and how to prepare the sample. Listen and learn. Thank you.
Hello everyone. Have you ever wondered how scientists are able to identify animals from a single strand of hair or diagnose genetic disease before symptoms appear? The answer lies in a powerful technique called electrophoresis. Today, I'm going to explain electrophoresis, how it works, different types of electrophoresis used in different laboratories around the world. Let's dive in. So, what exactly is electrophoresis? Simply put, electrophoresis is a laboratory technique that separates molecules based on their size and electrical charge. Think of it like a molecular racetrack. We use an electric field to make charged molecules move through a gel or other medium. The key players here are DNA, RNA, or protein, of which are carrier of charge. This technique is deliberately important. We use it for DNA fingerprinting in photonic science, analyzing protein, diagnosing genetic disorder, even in developing new medicine. There are several types of electrophoresis, each designed for a specific application. Let me walk you through the main ones. First, J electrophoresis. This is the most common type you will encounter. It uses a J matrix as a separating medium. There are two main varieties, that is agarose J electrophoresis and polyacrylamide J electrophoresis, also known as PAGE. Secondly, we have SDS PAGE. This stands for sodium doxysulfate polyacrylamide J electrophoresis. I know this technique is specifically designed for protein. Third, we have capillary electrophoresis. This is a modern automated technique. Instead of using gel, it uses a tiny glass tube and a capillary filled with a buffer solution. It is extremely fast and gives a high resolution result. Finally, this one of the oldest techniques, where filter paper soaked in a buffer is used as a supporting medium. While it is largely being replaced by modern advanced method, it is still used in some clinical laboratories. Agarose electrophoresis. What is agarose electrophoresis? Agarose electrophoresis is a technique used to separate DNA fragments and other macromolecules, such as DNA, protein, based on their size and charge. First step for DNA fragment separation in J electrophoresis is J preparation and J casting. First, agarose powder at appropriate amount is weighed out. For a standard J electrophoresis, molecules are dissolved using a low concentration, while small molecules are dissolved using a high concentration. Once the agarose is being weighed out, an appropriate buffer such as triacetate or tribromate, that is TAE or TBE buffer, is poured into the bottle. Agarose does not dissolve until it is heated. The solution poured into the bottle is heated for 2 minutes in a microwave. Once agarose is fully dissolved, the solution is collected to about 55 degrees centigrade in a water bath. While the solution is being cooled, an electrophoresis tank with a negative electrode, an electrode is prepared for staining. The combo is placed in the tank to create a way for loading sample. Casting dams are fixed in the tank so that agarose solution do not flow out during setting casting. When the agarose solution is being cooled to about 55 degrees centigrade, it should be removed before pouring it into electrophoresis tank. Etinium bromide is added. Etinium bromide is highly toxic reagent, so it should be carefully handled. Etinium bromide is an interconnecting agent which interconnects between base pair of DNA molecule. When the agarose solution containing etinium is exposed to UV light, it will fluoresce and DNA band become visible. The more DNA present, the brighter the band. After the addition of etinium bromide, the agarose solution is poured into electrophoresis tank. The gel is allowed to solidify at room temperature. Now we are going to look at how to prepare polyacrylamide gel electrophoresis. To run polyacrylamide gel electrophoresis, you must first assemble the gel apparatus, load the gel with buffer, and then carefully load your prepared sample and molecular weight marker into the well. Next, connect the apparatus to a power source, set the voltage, run the gel until the dye front has moved sufficiently down the well. Finally, turn off the power and disconnect the wire and remove the gel for staining and analysis.